All right, so where we left off last time, I gave you the complete intuition of the unit circle, what it's used for, blah, 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 how sine and cosine are defined. Now, how the fuck do we build this thing? So let's generate some angles. So the only two angles you need to really have memorized for the unit circle is pi over 6, which is 30 degrees, and pi over 4, which is 45 degrees. Okay, that's what their equivalents are. You should know how to convert between degrees and radians, by the way. That's something that you should know. If you don't know that, go look on YouTube, find some stuff, figure that one out, okay? So, the first group of angles are multiples of pi over 6. What the fuck does that mean? Let's have a look. So, ta-da! Here is my little Desmos graph that I've made. It's to help you see the pi over 6 angles. Okay, so here's my little thing, blah, blah, blah. There's 1 pi over 6, 2 pi over 6, 3 pi over 6, 4, 5, 6, 7, 8, 9, 10, 11, 12 pi over 6. If you simplify 12 pi over 6, what does that simplify down to? Oh shit, 2 pi, which is perfect because that's one complete rotation around the circle. That's what we want. 2 pi radians, remember, is one complete rotation. It's equivalent to 360 degrees. Okay, so what do you notice about this? First of all, the geometry of this is like a clock. Okay, so if you look at a regular clock, this would be 12, 1, 2, 3. So you know you're doing your pi over 6s properly if you generate a clock. Okay, it doesn't work the same way. You start over here. This is where you start, right? And then you go up the other way. Okay, so you're going counterclockwise. Anyway, so if you do 1 pi over 6, you get that one. This is 2 pi over 6. If it simplifies, the reason why, first of all, if you look at a thing here, okay, the blue ones, this is on Wikipedia. You can go type in unit circle on Wikipedia, you get this thing. If you look at the blue angles, those are all multiples of pi over 6. Okay, so why does it say pi over 3 if, Shell, you said that it's 2 pi over 6? Well, what does 2 pi over 6 simplify down to? Ah, yes, pi over 3. So all of these angles here you're going to see are simplified versions of what I'm about to tell you. So this is 2 pi over 6. Okay, the next one, 3 pi over 6. How does 3 pi over 6 simplify? Pi over 2. 4 pi over 6, 2 pi over 3. 5 pi over 6, 6 pi over 6 is right here, which is simplified to pi, which is perfect. Okay, see everything's working out nicely. That's 180. That's great. Everything's good. And then you just continue on like this. Okay, so you'll have to get the only angle you needed to memorize to generate all of these things is pi over 6. And in degrees, that's 30 degrees. Okay, that generates all this. Okay, isn't that awesome? Okay, cool. Now, I think that's all I wanted to say about pi over 6. Then we want to we need the multiples of pi over 4. We're only missing these 45-degree angle things. So that's these blue or purple lines that are added in there. This has all the angles. This picture here has all the angles in it. If you're counting the pi over 4s, there's 1 pi over 4 is that first one, 2 pi over 4. We already got that one. We know the 90 is covered by the pi over 6s, but it doesn't matter. That's fine. There's 3 pi over 4, 4 pi over 4, 5, 6, 7 pi over 4, 8 pi over 4, which simplifies down to 2 pi again. Okay. So notice that we only memorized two angles. We only memorized pi over 6 and pi over 4. And that generates all of the angles in the unit circle. Okay, so it just takes some practice simplifying down those fractions, but you need that practice anyways. It's good to know. You want to be sharp with that skill anyways. So learn that. Yeah, so that's how we generate the angles in the unit circle. Awesome. And I'll make both of these graphs available in this document. You can download the document and you get the links. That's in the description of this document. Let's generate the coordinates. Okay, so I made this one in GeoGebra. So let's just read this. Take a look at my GeoGebra example to have a good baseline understanding of how to assign values to the unit circle. The graph can be found here. Okay. So if we look at GeoGebra, which looks like this one, let's close this shit down there. Okay. So don't worry that it looks all fucky right now. Okay, I'm just going to explain. I just drew it like this so that you could see what's going on. You won't ever look at it like this again, but it'll really help you out. So you have these coordinates here. Okay, here's what you need to know about the coordinates. This is why the coordinates are really actually easy on the unit circle. It looks like, oh fuck, that would be hard because look at it. There's all this shit here. It's like this is going to be hard to do. No, it's not going to be hard to do, actually, which is really nice. You only ever have these three coordinates. Okay, so it's plus or minus root 1 over 2, which is just a half. Okay, I'm doing root 1 over 2 so that you can see the pattern. It's root 1, root 2, then root 3, all over 2. Okay, or you have negative root 1, negative root 2, negative root 3, all over 2. That's it. If you look at all of these coordinates, it's one of those 6. Okay, any one of these things. Now, okay, how do we assign those? How do we know which one goes where? Well, let's just look. Okay, let's look at the x coordinates of these first 3 points. Okay, I drew a line here so that you can compare the x coordinates. This x coordinate is the smallest, the top point here of the three in this quadrant, okay, this first quadrant. The top point has the smallest x value because it's the closest one to the y-axis. The next one has the next smallest, or the next biggest, or next smallest, x value because it's the middle distance. Okay, it's the next furthest away from the y-axis, and then this one is the furthest one away from the y-axis. So if I and notice that all of these distances are positive because I'm starting at the y-axis and going in the positive direction. I think in the video that's backwards, so like that or whatever. You know what I'm saying. So if I had to assign values, I couldn't assign these negative values. I would have to take these positive values. This top one would get the smallest value, which is root 1 over 2. The middle one would get root 2 over 2. And this one would get root 3 over 3. So these are the x coordinates of these points here. I'll put them over here. Boom, boom, boom. Okay, so that's all you have to do. As long as you know what your options are for your coordinate values, you can just logic these things and say, well, this is the smallest x value, so it has to have the smallest coordinate of the three, and the next, blah, blah, blah. That's how you do them. Now the heights, this one here is the shortest height. This is the next shortest height, and this is the tallest height. So the height for this point would be, it would be backwards, right? The heights would be like this. So the middle one stays at root 2 over 2. Okay, so I drew this one here for practice on the y values, the y coordinates, okay? So the y coordinate, this one is negative, and it's the shortest one. So this y coordinate would get negative root 1 over 2. This y coordinate gets the next one, the next biggest one, and then the last one gets this one here. So if I said, what's sine of this angle here, which is 9 pi over 6 minus 1, 8 pi over 6, so 4 pi over 3. So I said, what's sine of 4 pi over 3, which is all the way up to that angle there? You would say it's the height of that point, which is negative root 3 over 2. Okay, so as long as you know the x and y coordinates of all the points, which, as I just showed you how to get them, you can get the sine and cosine values for any point on the unit circle. That's how you generate the coordinates. Okay, so you'll notice that if you look at something like this, it's already done. Let's look at these. Let's look at these points here for a little bit of practice. Okay, the x coordinate of this point is the greatest one, and it's positive. That's why it's root 3 over 2. The y value is the closest to 0, so it's negative 1 over 2, which is the same as negative root 1 over 2. So if I said, what is sine of 11 pi over 6? You now know how sine is defined properly, so you would just say, oh, it's negative 1 over 2. Okay, if I said, what's cosine of 7 pi over 4, you would just say, oh, it's root 2 over 2. All right, and if I said whatever, okay, do you kind of get the point there? All right, so yeah, that's how you generate the coordinates. You only need to memorize plus and minus 1 over 2, plus and minus root 2 over 2, plus and minus root 3 over 2, and then you just place them in the way that they logically have to go. There's no real guesswork that's involved there. Okay, once you understand the rules, it really is easier than an easy Sudoku puzzle. Okay, should be no guesswork. Okay, so we generated the coordinates, and then now, okay, once you have a basic idea of how to do that, you need to practice your damn ass off. Okay, it probably, I would estimate, would take you maybe 30 minutes a day for 2 weeks, and then you're going to be fine with it, and then it's going to be no problem at all. So I gave you two online practice things. Okay, you don't need to pay any money for this shit. This shit's all over the web. My favorite one is this guy's. It's Tall Jerome. It's the second link there. There it is, Tall Jerome, NOLA, blah, 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 whatever. It just gives you, it's kind of big right now. Let's see, there we go. Okay, so it gives you a value, and then you have to like figure out where that is, which of the like points that's referring to, and then you have to put in this case, the x coordinate. Okay, it has some cosecant values and stuff. I think in the options you can make it a little bit easier. Time, unit sign, display circle. Yes, so you can display the unit circle. It looks like, okay, you're going to get some of the cotangents, cosecants, and whatever. Maybe use this one when you're a little bit more advanced. But there's another one that I gave you in the description, or Khan Academy is great for that as well, where you can practice. And then, but this Tall Jerome one, you know you have it down when you can do these this Tall Jerome thing in like all 15 right in under like 10 seconds a piece. Okay, then you're golden. You don't have to worry about it. You've memorized your unit circle and you don't have to stress about that anymore. Okay, so hopefully that is a good comprehensive review of the unit circle. If ever you forget, if ever you need to relearn something about the unit circle, you're like, wait, why is it the x coordinates that are related to cosine and the y coordinates related to sine? Come back and you can watch this video, okay? Yeah, I hope that helps. If you guys have other questions you want me to answer, just either like shoot me a message or put it in the comments of this thing. I'll be doing about a video a day. So I hope that helps. Yeah, and we'll talk to you guys next time. Peace.